It's question show time. Your questions, my answers, as always, wherever you are on my channel. Question pops in your brain, write it down, I gather them up, and I answer them here. Let's just get into it. Matthew Stevens. Have there been any proposals to visit objects like Sedna or Haumea using solar sail technology? Would this be practical? There have not been any proposals to use solar sails to visit those objects yet, or really any objects in the outer solar system. The closest idea is, of course, the Breakthrough Starshot, which has been proposed to study Alpha Centauri, Proxima Centauri, but not the outer solar system, which I think is the natural fit. So my hope is that when the Breakthrough Starshot actually goes into some kind of prototype, they start sending these tiny little nanoprobes at the various objects in the solar system. Why not? Let's just try. Launch 1,000 of them into space, shoot them with little lasers, and see if you can get some close-up images of some of these different Kuiper Belt objects and asteroids and comets, and see what's out there. Now, one idea, and I've mentioned this in a whole video, so solar sails are not great because the farther they get away from the sun, they start to lose light pressure. But there's this idea of an electric sail, which uses essentially the charged particles of the solar wind as a propulsive force. And that extends quite far out, and you can actually go very fast. And so there was a proposal to use an electric sail to go into the outer solar system and explore some of these regions. So I'll put a link in the show notes so you can go and check out that video and look into electric sail. So another idea, surfing on the sun's radiation power, but kind of a different way. But it's cool. Michael Schiffman. I saw a couple of videos about principal investigators getting 500 samples of Apollo moon rocks per year from NASA. What could the next test possibly tell us that the previous 10,000 didn't? Do they share the test results to minimize the need for repeating a test? Man, imagine if you told geologists, right? Like, we're going to take a bunch of rocks from 5 spots on the Earth, pile them up in a big bag, mix them up, dump them in front of you, and that's all you get to learn about the Earth, right? It's crazy. Geologists want to know about every single part of the moon, and so they're going to want samples from all over it. But even these individual samples that have already come up, yeah, they are going to learn new things. There's one piece of research, and we also did another video about this, which I'll put a link in the show notes, about how they've discovered maybe an early chunk of the Earth ended up in the moon. So early on in Earth's history, a big meteor struck the Earth, gouged out a bunch of material, it flew into orbit, ended up on the moon, and then it got pounded up while it was on the moon, got driven down below on the moon, and then another meteorite scooped it up and delivered it back on the surface. And it's kind of been mashed in with other rocks into this sort of aggregate lunar material. It's a 1 in 1,000 sample, maybe, and it tells us something about the early Earth. So the geologists who are studying these lunar samples, I guarantee, want to keep studying, and they want more, and they want them from different locations, and they want to just keep trying to understand. They're trying to piece together the history of the Earth and the moon, and that only comes together through tons and tons of evidence and really careful analysis. So I think you could give them 1 million samples and they would love more, please. As many as you can bring. Brian. If Jupiter bumped into the Earth, is there any chance the Earth could survive? Would it be possible to retain its atmosphere inside of Jupiter? No. No way. First, let's think about Jupiter, right? Jupiter is 1% of the solar system. Anyway, the sun is 99% of the solar system with its hydrogen and its helium, but Jupiter is essentially made of the same stuff, hydrogen and helium. And you would think that that would be like a gas, right? It'd be this fluffy place that the Earth could go into and it would just float around inside. But that's not what Jupiter is. It is under immense temperature and pressure so that the gravity is pulling it in. And once you get down really just a few hundred kilometers into the surface of Jupiter, you're getting this hydrogen and helium that is compressed so tight together that it's starting to act like a liquid. And when you actually get into the core of Jupiter, it is more dense than the densest metal you can possibly find here on Earth. And yet it's still just hydrogen and helium just mashed together. So Jupiter is not this fluffy gas cloud that the Earth could go through. No, if the Earth somehow got close to Jupiter, it would be torn apart. It would be torn apart before it even hit Jupiter. Once it went in with the Roche limit, the gravitational force on the front side of the Earth would be stronger than the gravitational force on the far side of the Earth, and it would just tear it apart, turn it into a ring, gobble up the ring, and a few weeks later, we would never even have known there was an Earth there. So do not do this, please. Max exposure. Hey Fraser, love the channel. Is the size of our gas giants related to their distance from the sun? If they were the same distance as the Earth is from the sun, would their size change? This is a good question, and the answer is that astronomers still don't entirely know. I mean, the sort of the more general question that you could ask is the solar system normal? Right? Is what we find with a bunch of terrestrial planets close in, with gas giants, with the ice giants farther out, with the Kuiper Belt, is that what you would expect to see? And 20 years ago, if you talk to planetary researchers, their guess is that they would see roughly the same kind of thing. They thought they understood the sorts of forces that happen, how the heavier elements are close into the sun, then you've got the lighter elements, and they form these different sized worlds. But now astronomers are finding that all kinds of combinations. There's this great, I hope Chad can find it, where this shows all of these different examples of planetary systems that have been found so far. And of course, you've got the hot Jupiters, where you've got planets that are many times the mass of Jupiter, really close into the sun, orbiting faster more often than Mercury does. And you've got examples of much larger, more massive planets than Jupiter orbiting stars. So the general forces that are going on in solar systems seem to be the same. You've got this flattening of this disk of material. You've got nuggets form into planets depending on sort of the amount of material that's available. They carve out these gaps. They move around as the remaining material in the solar system gets finished up into these planets. In the case of our solar system, right, Uranus and Neptune switched places as they migrated and moved around, and astronomers are still trying to gather examples of what these other solar systems look like to see just how normal is the solar system. Or could you have this situation where you've got a giant gas giant like Jupiter in the orbit of Earth? Maybe you could have a Earth-like planet as a moon. Katsu Zatoshi. If we meet intelligent aliens on Mars and they have a totally different explanation for how the universe works, what will you do, Fraser? Simply ignore them, ridicule them, start quarreling, or what? A totally different understanding of laws of nature and stuff can ruin hundreds of your videos, for example. Perhaps we must rearrange the periodic table. It could easily develop to a total disaster. What do we do? When we meet the aliens, probably the first thing that we're going to do is go, here are the laws of physics as we understand them. Are they the laws of physics as you understand them? And the expectation is that they should be the same. That we have discovered the mass of hydrogen. They will have discovered the mass of hydrogen. We have discovered the speed of light. They will have discovered the speed of light. We have discovered this force of gravity. And that all of these properties of the universe are universal. So I would expect that 99% of the things that we exchange, the pieces of information, will be exactly the same, because that's how the universe just works. We live in it, but the universe has its own set of rules, and we have discovered them. The fascinating stuff would be, when they say, here's how this thing works, and we're like, we think that thing works like this. And suddenly you've got this disagreement, and now you know that one of you is right and one of you is wrong. And so then the goal is to figure out which of you is right and which of you is wrong. And the way you do that is with science. You present your evidence and you look for things that can, new pieces, new hypotheses, new ways to test your ideas. And quickly, we and the aliens would run through all these things that we disagree on, and we would come to a new understanding. Some we would have to reject our own ideas. They would have to reject some of their ideas. And really, this is just how science works. Like all the time, scientists are saying, I think this works like this, and another scientist says, I think it works like that, and they do experiments, and they gather evidence, and they try to convince each other through the evidence, which is probably a better explanation for how nature works. And so if we got to aliens, it would be like a real creative time, because we would have encountering all these new ideas. So it would be fast. I'd love to be there as they are exchanging these ideas. So I hope it happens. Time of dying. You say that space telescopes will never make land telescopes obsolete. Could there be any other celestial body in our solar system that might be ideal for planting a telescope on? I think in general, telescopes, like the reason we want a telescope on Earth is because it's accessible, right? It's convenient. So we can just go down to the telescope and we can change the instruments and we can fine tune it, and just hang out with the telescope, right? Give it a hug. So I think that's why you want an Earth-based telescope. It is worse than a space-based telescope. By every other measure, a space-based telescope is going to be better. It's got no atmosphere to go through. It doesn't have the gravity pulling it down, distorting its mirror. It doesn't have dirt and dust that's flying around in the atmosphere that's clogging it up. So a space-based telescope will always be a vastly superior experience. It's just incredibly expensive. So I can't imagine why you would then want to go through the expense of getting a telescope to another place, but then putting it back down on the ground. That would be madness. So I've heard people say that it would be kind of cool to put one on the moon, where you, for example, could be on the far side of the moon and then you'd be blocked by the electromagnetic transmissions that are happening from Earth. And so you could have a really good radio telescope that has a view of the universe without being bombarded with signals from Earth. That's a great idea, right? So then you're blocking the signals with the moon. There's probably some other ideas, like really special situations, but I think in general, space is the best place to put a telescope. And if you have less money and you want it to be more convenient, you put it on Earth. William Bays. I was just watching What Da Math with Anton Petrov. A question popped in my head about part of it. He mentioned dwarf galaxies and wondered, what is the difference between dwarf galaxies and globular clusters? Are globular clusters just dwarf galaxies that failed? No, maybe? So globular clusters are these amazing structures. I've done a whole episode on them. That's like 3 so far for this question show. They're these balls of stars that can contain millions of stars in them, but they're in this tight, compact ball, and they are old. They are some of the first structures that formed as early on of the Milky Way. And so there's still a couple of ideas about where these things come from. One of the ideas is that they formed early on in the galaxy from really big clouds of hydrogen and helium when there was a lot more available in the universe. And the other idea is that they are like the cores of dwarf galaxies that when they got consumed by the Milky Way and they got all of their material stripped away, and this globular cluster is all that remains. We have definitely stolen globular clusters from the various other galaxies that we formed with. And still, where they formed, where they come from, why they're so old is still a bit of an open mystery. So, good question. Josh M. How could astronauts on the surface of Mars travel without being exposed to too much radiation? Could a vehicle have water shielding? I love this idea of a rover on Mars having like a meter-thick water roof covered by steel or something to stop it from sublimating away from the sun's radiation. That would be really heavy, even on Mars. It would be a very strange vehicle. Water does make one of the best methods of insulation, really just protons. If you can get protons between you and radiation, you're protected. And in this case, yeah, you have a meter of water. It will protect you as well as if you're just here on Earth under our magnetosphere and an atmosphere. So, but still, it's very heavy. So no, I think the way the astronauts on Mars are going to deal with it is they're going to minimize the amount of time that they spend outside of their holes in the ground where they live their whole lives. Because every second that you spend out on the surface of Mars, the radiation is beating down on you and it's going to increase your risk of getting cancer down the road. And you just think, like if you knew that every time you stepped outside, although I guess we kind of do with sun sunburns and skin cancer. But every second that you went outside, the clock started, and you knew that you were increasing your risk of some kind of cancer down the road. And it's just probably going to be too heavy. They're just going to put as much shielding as they can afford to put on the rover, and they're just going to spend as little time outside as possible. Which again, if you want to go live on Mars, you're really living in a tube underground on Mars. The Game Crasher, the Master Gamer. Do you play any tabletop role-playing games? Do I ever? You're going to have to Google this, but I've actually written several role-playing games for several different companies. So I wrote a Shadowrun role-playing game adventure. I collaborated on another Shadowrun project, a couple of them. I wrote a supplement for the Earth Dawn game. I did the bestiary for Earth Dawn. I contributed to the Horrors book that they did, and I did a supplement with my friend Nigel Findlay for GURPS. I did a sort of a generic characters that you could use. So I did like maybe 5 or 6 books back when I was like 19, 20, 21, and I'm 47 now, so it was a long time ago, another life. And that was originally, that's what I wanted to do. I wanted to be a writer. I wanted to be a role-playing game writer. And I worked in a comic book store in Vancouver, the Comic Shop. Anyone who remembers, who lives in Vancouver, remembers this place. I ran the gaming section of the Comic Shop and had a regular crew. I organized a big role-playing game convention in Vancouver for 3 years. We had a great time. And I've had regular gaming sessions for decades. D&D, more recently Ars Magica, and haven't played for a little while, mostly just because I'm busy. That's how life works. But the kids are into it. We've played with them, and now they have some pretty good adventures. So yeah, I'm 100% into games. Also play a lot of board games, have played a lot of board games. You know, like the Carcassones and the Ticket to Rides and the various exotic German board games, which are super fun. Race for the Galaxy. So, yeah. And we used to do a game night a couple of years ago, at our local bike shop. We would, once a week, we'd all gather together and bring a bunch of board games and play them. So, yeah. Role-playing games, board games, and video games. I have the nerd trifecta. AK lover. The problem with government-funded science is that it's not outcome ends-based. Once the funding is laying down, a narrow focus and clear end game should be there. Instead of studying gravitational waves, broadly work out how to manipulate gravity, for instance. Engineering, by that I mean engineers, fabricators, mechanics, etc., should be forcibly tied to scientific research. Wow, that's tough. I don't think so. I think that science, like, we don't know what the science will turn into. And so, sure, there are engineers and they should be working to come up with practical applications, and there are all kinds of side benefits that happen. But I think there's value to pure research, to just understand how the universe works, how nature, what the laws of nature are. And you will discover through studying different kinds of materials and different kinds of energy and different kinds of laws of physics and chemistry and biology, you will start to have these glimpses, and they turn into practical applications down the road. And I think that, in fact, if we try to figure out what we're trying to figure out in advance, then we lose these wonderful serendipitous discoveries about just how the universe works, which later on turn into practical applications, like lasers and the silicon that went into making computer chips. So not so many rules, man. Like, let's just chill out. Let's just learn about the universe. And if people want to figure out how to control gravity later on, they can. But I think people should just be free, and I think there should be a sizable amount of money that is funded to just understanding how all this works. Here I am, we're on the internet, right? I've got a microphone, I've got a smartphone, there's satellites, we use lasers, like all this stuff gets figured out as part of the process, and it's working really well. So let's keep doing it. Greg78. Since the moon has practically no atmosphere, can we make a satellite orbit, say a meter off the surface? 1 meter above the highest point? If the moon was a perfect sphere and the Earth didn't exist, then yes, you could have something orbit very close to the surface of the moon and go around and around and around, and it would probably be able to last for a very long time. But I just explained those two things. One, the moon isn't a perfect sphere. The moon is bumpy gravitationally, right? It's got different densities of different kinds of rock and metal and mountains and craters and all kinds of stuff inside of it. And so as a satellite is trying to follow this orbit around the moon, it's actually kind of moving in and out and up and down, and it's getting distorted as it goes around. But the bigger influence, of course, is the presence of the Earth, which is an enormous amount of gravity. And so when the satellite is on the same side as the Earth, it's being pulled towards the Earth a bit, and the Earth is distorting the orbit of a satellite that's going around the moon. And the moon is actually tricky to orbit for any long period of time. And many satellites have started out orbiting the moon, and they've got a limited lifespan because of all these interactions. They crash after a few years, unless you've got like a good source of fuel for a long period of time. Right now, the Lunar Reconnaissance Orbiter is up there. It's been there for a long time, but I'm sure once it runs out of fuel, it'll just be a matter of time before it crashes into the moon, because it's a notoriously difficult place to orbit for any long period of time because of all the forces that are acting all at the same time. While, say, with the Earth is the dominant gravity in the area, and so satellites can go around it for a long time. As I said, hundreds, thousands of years. Mika. Hey Fraser, for those of us that live in cities with a lot of light pollution, do you know of a good app website that tells you where the closest non-polluted area is? I would love to check out the stars one night, but I don't know how long I'd have to travel to do so. I know just the site for you. So it's called the Dark Sky Finder, and it is a map of light pollution. So for me in Courtney, we've got pretty good dark skies. I can see the Milky Way from my backyard. For a lot of the places on the east coast of the United States, there's almost no spots, but there are a few which are green and go down to blue. So if you can get yourself to a green or a blue area, you should be set. And so even in New York City, I think there's like some mountains that are about a 2-hour drive away. So wherever you live, unless you live in like Holland, Belgium, there's some places in Western Europe that are really, really hard to get away from the light pollution. You're going to need to do a longer road trip. But yeah, use Dark Sky Finder, find a location, make a plan. Tell me in the comments that you did it. I would love to hear. All right, that's it. As you can see, it's starting to get a little dark, so it's time to wrap up this week's question show. Thank you everyone who took the time to write out questions. I really enjoy the interaction with all of you, so keep them coming. I love the ideas, the questions, and we'll see you all next week.